Welcome to the Databricks Skill Builder series. We're glad you're here.
And at some point, if anyone wants to speak, I'll just unmute you and so you can speak. Yeah, I'll just begin right here. So I guess the first thing is, before I go, how many of you are also familiar with Delta Live Table? Just do a +1 if you are in the chat as well. Just wanted to get a feel of that. So yeah, so just right off the bat, right? The what I wanted to really get across is on DLT is that the whole point here is to make it easy to build and manage reliable batch and streaming data pipeline that delivers really high quality data on the platform. And it does helps, the data engineering team simplify ETL development and management with the declarative pipeline development and be able to automate the data and testing and have a deep visibility for monitoring and recovery. There are a few there are some main benefits in regards to DLT, and one of them is to be able to accelerate ETL development, and that is being able to apply a modern software engineering best practices to be able to deploy a pipeline at scale and enable data analysts and engineers to be able to use this declarative API either in Python or in SQL. And with that, it also gives you that ease to be able to have a built-in streaming processing. So that's one of the things that it does. And it also allows you to be able to manage your infrastructure, right? Automatically manage your infrastructure. And that is being able to remove the overhead by automating complex and time-consuming activities like, task orchestration, error handling and recovery, maybe auto scaling and performance optimization. And so with that, we also have a built-in testing and CI/CD, and the pipeline optimization and performance tuning is also built in as well to be able to help you do that. And it also has a tax operational statistics and quality metrics that it provides. Also, as you do this pipeline development, you want to have confidence in your data, right? So DLT delivers a reliable data with the built-in quality control, testing, monitoring, and really an enforcement to ensure accurate and useful BI, data science, and machine learning, right? And so we also have a full lineage tracking of your data, and also has the data quality metrics monitoring built in. And then last is also be able to simplify your batch and streaming workloads, right? So it does provide you with the freshest, up-to-date data for your applications with a data self-optimized and auto-scaling data pipeline for the batch and streaming workloads. And so with that, then I'll jump into really the next screen here, right? So when you look at DLT, it automatically handles the error handling and automatically recovers from failure without any user intervention at all, right? And the tool really provides you to be able to troubleshoot bad data with a granular pipeline observability. So you get that high fidelity lineage diagram of your pipeline to be able to track dependencies and aggregate data quality metrics across all your pipelines. So what you see on the screen here is basically all the green highlights or letters that you see, right, are things that Databricks really takes it from you as an engineer or as a machine learning engineer, right? So trying to figure out continuous and batch streaming, trying to figure out the error handling, trying to figure out orchestrations and everything. We take care of the headache for you. So that as an engineer, all you need to worry about is the data transformations and the data quality, and then also the business level aggregation that you've been assigned to, so that you don't have to deal with all this plethora of tools trying to figure out, oh, I need to figure out how all these things work before you even come down to trying to develop the actual transformations of the data that you have. So that leads me into really the data streaming within the lakehouse, right? And so what I really want to, I wanted you to get out of this is, to also know that, right, streaming belongs to the lakehouse, right? And to do this, there are three main use cases that we have seen customers pursue, and we tackle very, very easy on our platform. And that is real-time analytics, real-time machine learning, and real-time applications. So on your screen here, right, is that with using the Databricks platform, is really made up of, a tightly integrated product that works together seamlessly to support your real-time analytics, that is, as I mentioned before, and the machine learning and the real-time application. And these are all done on that one single platform. Within Databricks, you have the autoloader, right? And we're using that autoloader and some of our message buses connectors, you can quickly and easily connect to a variety of different streams of data from the cloud or to a pub self-service like your Apache Kafka or an event hub. And so when data is then continuously ingested into the Delta Lake, which is really just an open for storage layer that delivers that reliability, security, and the performance of your data lake, right? And this is designed for both streaming and batch workloads. And underneath here is really the Unity catalog, right? Which is a unified governance model to find, secure, and share your real-time and historical data with individuals within your team and even external organizations. And this governance model applies to all assets of your data, including your notebooks, your dashboards, your machine learning models, in addition to your streaming data tables as well. The next in line here is the Photon, right? Which is this next generation vectorized execution engine, providing that record-breaking performance to process your streaming and batch workloads. So with, as you can see here, we have real-time structured streaming data, and then you have the Delta Live table, right? Which makes the building and maintaining of your streaming and batch pipeline really simple for, as I said, for your analysts and your different personas, like your data engineers. And then you have the workflow, which enables them to be able to orchestrate the reliable production of their workloads. So when you combine the Databricks SQL, then you have all the capabilities you need to be able to build a real-time data warehouse and a real-time analytics, enabling your business, right, to be able to make a faster decision as the data comes in fresh, right? And then so the Delta Live table and the workflow really also unlocks real-time machine learning. So when your data is streaming, you can now leverage the Databricks ML platform and deploy real-time features to train your models and on the freshest data and instantly score new data, being able to make predictions faster and much more accurately. Then you have the structured streaming, right, which lies in the heart of the Lakehouse platform in terms of the real-time capabilities. And this is, widely adopted by a lot of individuals and organizations, and it provides that single and unified API for batch and streaming processes, really making it easy for data engineers and developers to build real-time applications on the Lakehouse platform without changing the code or even trying to learn new skills. And so with all this, right, what I want to make sure is you get is, the Lakehouse platform offers all these tightly integrated capabilities to support, your real-time use cases in that single platform. And so I wanted to make sure I get that across, just to make sure you understand that. And then from there, that is all being served to your real-time BI and your real-time applications as well. So now I would like to jump into the demo, right? Really to showcase you how DLT is used for streaming, right? And so with that, I will show you, we're going to jump into the Databricks platform for the folks of you who haven't really dive into it or seen it before. So normally, right, when you get into the platform, this is how it looks like, right? You have the different personas, which is your data engineer, your machine learning, and your SQL. And so you click on your data engineer, you have your workspaces, your repos, where your data is stored, and your compute, right? For the sake of this, we're going to use the workflows, right? And so basically, we want to be able to set up real-time analytics and real-time machine learning using DLT, right? And these are all located under the workflow. So we click workflow. And so once we click workflow, you have Delta Live table here, right? And so the first thing we do is to create a pipeline. So normally what you do is to create a pipeline, you give it the pipeline name, right? And then here we have advanced, pro, but really these are different editions that you can select depending on your use case and depending on what you're trying to do, right? And so for if you're doing advanced stuff, some of this, for instance, the advanced one, it has a CDC built in it. And so if you want to be able to do a CDC and be able to have a quality expectations and monitoring, you want to be able to use the advanced, which handles both that and also maximizes your credibility with your data quality and expectations. So that is what that does. And then I think the Pro does the same thing, but it doesn't give you that quality expectations and monitoring. And then the least one is the Core, which doesn't have the CDC and the monitoring as well. So normally, with a lot of customers that I've worked with, they select the advanced based on some of the use case that they're doing. So you select that, and then you have the pipeline mode, which is a trigger and a continuous, right? And this is a knob that you can tune based on your SLA. And this lives outside of DLT so that you don't have to make any changes within your code. And so the trigger mode acts like a batch mode, meaning, once your job streaming is done, it can turn off when your message are read. And also you can set up a schedule for the next run. And then then you have the continuous mode, which is more like a always on use case for when data is coming in every second and you don't want to shut it off, right? And so that is what that is for. And then this is where you select your notebooks, right? So imagine that you're working with a lot of the developers, right? That's the beauty about the platform, right? In terms of, hey, I have users from different places that are developing this code. I want to be able to pick up the notebooks and be able to create a flow so that, maybe one notebook will depend on the other, right? So you have users here. And if you click on those users, right, you can get access to the different notebooks. And then you might be sharing some notebooks as well. So maybe you want to pick up those notebooks as well, or it's coming from a repo, right? And so those repos, depending on where that files are located, you can pick that up and then get that read. So I wouldn't pick that up because I've already developed that pipeline, but I want to show you how that is set up. And then you have your destination. This is a new feature that just get added on, right? This is the storage location, whether you want to store it in Hive Metastore or Unity Catalog. So previously, if without a Unity Catalog, what happens is that when you run your DLT pipelines, all your tables, everything gets stored under the Hive Metastore. And so then if you're a company that have already set up a Unity Catalog and DLT doesn't support it, what happens is that your data gets written to the Hive Metastore. You might have a sync job that if your data is written to an external location, you might have a sync job that will sync your data from the Hive Metastore into the Unity Catalog. And if it's a managed table, you might have to do like a copy command, maybe set up a job that will automatically copy the data from the Hive Metastore into the Unity Catalog, right? And so with that being enabled now, you can just select Unity Catalog and give it a catalog name, and then also give it the target schema, right? To be able to, for that to be able to be written to. So it gives you that flexibility and the options to select, depending on whether you're using Unity or you're using the Hive Metastore. And then you have your compute, right? In this case, auto scaling, right? And so with auto scaling, in the streaming world, right, there's a pickup time to your data set where, you need more compute, right? And so in a scenario where DLT has an auto scaling enabled, right, for your cloud or maybe for Kafka, as you read your messages in, it sets a min and max workers so that you can have that in case you have a huge workload, the cluster can scale up when when there is less workload or data set to be processed, it can also scale down. And this is the reason we have that. You're going to be able to, we have that min and max just to help you reduce cost. And so those are some of the settings that you want to set to create your pipeline. And you can have everything within a JSON format. If you want to be able to replicate that across maybe different workspaces, you can create everything in the JSON, or just set it up and then you can just click the JSON. It'll give you all the configurations. You can copy it and then save it and edit it, and then maybe apply it to other different pipelines on different workspace. So that is the pipeline creation. So I would like to jump into the already developed one just for the sake of time to show you how that works. So I've already run this before, but I'm going to restart that pipeline and basically click refresh all. And the reason why I did that is because If I hadn't started that just for the sake of the call, it might take some time. So I've already run it once. So if you run it again, it just doesn't take that long. So now this is going to be running. And so you have two screens. You have, this is where the DAGs will be created. And this is where the other pipeline details are located, right? And so in here, you have your notebooks that you're going to be referencing within the pipelines that will be created. And these are dependent upon each other. And so, and then you have the pipeline details, the updates, and then the compute that is using. And then you have the cluster, which is the Spark UI, the logs, and the metrics that you can look at. So as this goes on, I would like to jump into one of the notebooks. So I mentioned that this is a wind turbine scenario, which is more sometimes in the manufacturing, manufacturing world, right? And so this is how really the diagram looks like, where we have a wind turbine, and we're going to be reading from a sensor data, right? And so, you know, with this, we're going to be streaming from, getting the data from Kafka, right? Since the data lives in Kafka, we want to use some Spark connectors to connect to our Kafka, set up a configurations, right? And then, and since this is a file, we're going to be reading a sample file and getting the schema from that file. And then, you know, with that, you can also use, you know, maybe a Kafka schema registry as well, or you can also infer the schema based on the column value. We are also setting up a topic name. In this case, we're creating it, we're parameterizing it so that we can be able to use it when we're setting up our DLT in terms of the topic we want to pass, right? And so it will pick it up from there. And so that is how we're setting that up. So once you have your Kafka and everything set up, now the next thing is you want to be able to now read creating your bronze layer, right? So now we're going to use the declarative API within DLT and use a function to create the bronze table, which lives in the S3 bucket that we provided during the setup of the pipeline. And so basically in a return statement, we are doing some select. So basically, as in here, we set up the spark.readstream. We apply a few options. These are configurations within the Spark. And then from there, we load the data. And so once that is loaded, we're using the declarative API, we're creating a function, right? This is basically going to be your table name, your bronze table name. Again, we work on a medallion architecture, which is your bronze, your silver, and your gold, right? And so we create our bronze layer, and then the return is basically a select statement, right? And using the from JSON function, right? Using that from JSON function, this JSON that we are reading is a nested JSON, right? So we do some transformations, and because it's nested, we want to be able to use the explode function and try to flatten out the JSON, be able to bring the top level column on the top, right, in terms of the table. So it's going to convert your JSON strings into struct type or a map type. So that is what this is doing. So now imagine that, okay, your bronze layer is done, data is coming in from Kafka, you stream that in, you have your data in your bronze layer. So then that leads us into our next layer, which is basically our silver layer, right? And so within our silver layer, we've ingested the data incrementally from that, and then now we're trying to get into our silver layer. And so in our silver layer, basically what we're going to be doing, right, is that we now want to be able to do some machine learning, right? But in order to do that, we need to clean up the data, and the ability to do that is to do a continuous stream by creating a streaming table, right? And so when you're creating a streaming table, what you want to do is to be able to create the table statement and have a streaming live, and the streaming live is associated within it. And so this is because it will incrementally read in the data from the streaming source. So this is the streaming source, right? And so this is streaming from the bronze. So imagine that as the data lands into the bronze layer, with this streaming live, it will automatically pick it up, right? And then per the transformations that we have, it will then write it into the silver layer. So that is what it's currently doing, right? And also, we can also, as that loads up and comes in, we want to be able to also set up some quality metrics on top of that, right? We want to be able to do that. And so with that, we are using the constraint. So the constraint is saying, hey, you know what? I want to be able to check to see if the ID is not null or if the ID is greater than 0, right? So this is a constraint that we're adding to the data that we are ingesting from the bronze layer. And then we can also add comments to that as well. So that is the comment we are adding here, just to really identify the table that we are reading and the comment that we've been added. So that is what this particular one is doing. And so once that is created, we want to now be able to build and train some models, right, and do that. And so to be able to do that, right, now we want to be able to do that predictions on our sensor data. So with the sensor data, you know, you can think of it as, you know, you have your features with your feature column, right? And so now what we need is labels with that column, which will help out in doing the training and testing against to be able to do our predictions. And so what we're going to have is more of like a lookup table, right, which is written in Parquet, right? And we're going to be creating the table based on that. And so this will give us, you know, a status of the sensor data, whether the turbine is healthy or is not healthy, right? And so here, we're not going to be doing streaming because this is going to be more of a static table where we're going to be doing a full load, right? And so we're going to be using live instead of streaming. And that is what this is doing. Instead of doing streaming, we're just doing live. So this is just a static table that we're going to be loading that in, doing a full load of that. So it will not be a streaming table. And then the schema is inferred based on the format that we are using. So once we have loaded that in, now we want to be able to join that. So now we've created the status table that we have. We want to be able to, you know, somehow join that to our basically the server table that we have created. So that is what this is doing. So now the next is, as we said, we're going to be joining that server table and create a table for the machine learning folks. So that is what this will be doing. So we're creating a streaming live here, right? Giving the comment, doing a select from that and joining the server layer to the status table that we created using the ID. So we're joining those two together. And so once we have those two joined together, now the next thing is to create the final layer, the bronze layer, right? To be able to make predictions on. And so we've read the data in, we've cleaned it up, right? We've joined it with the static data, which we have here. So now we want to be able to, you know, do some machine learning models, right? And so to do the machine learning models, the picture that you see here that has ML flow, we're going to assume, right? We are on the assumption that your machine learning folks are going to be creating this training data set in real time. You've provided this to the machine learning, and you're creating this real-time data streaming. You provided it to the machine learning folks where they're going to automate the process to be able to read this data and do a train and test against it. And once you create this model in real time, then we pick up the best model and publish it into the model registry, right? And so this is assuming that we've done all that stuff. We have the best model in the registry. So with the best model published, then I can apply regular sensor data to that is coming from Kafka. And so with that, in this case, we're just going to load up the model, right, from the given path. In this case, this is the path that was given to us where the model is located. So we're going to load it up, and then basically register this as a UDF. And this, we are doing that because we want to be able to do some scoring against the data. So that is what this portion is doing. Let me see if there were any questions that were coming up. Okay, there are no questions so far. So that is what that aspect is doing, right? And so once we have that, now we're going to again use our declarative API to create our final table. And we're going to read from the server layer using the UDF with that model, with a model on it, and then try to provide or create a different field. So we're going to read again, the return is reading the stream from the sensor server table. We're doing a select of these columns, and we add in an alias, just a new column. And this is basically where the status of whether the turbine failed or turbine did not fail, that is where they're going to reside. And so once that is done, we just want to be able to select from that, just to show you how that looks like. So you have 0 and 1. So 0 meaning that the turbine didn't fail, and 1 means the turbine failed. So that is the information that it gives us. So once you have all that done, now you can imagine that you want to be able to have this flow and be able to get a real-time dashboards that gets created based on a series of events in terms of reading the data into the bronze layer, doing the transformations, the silver layer, doing a few joins within the gold layer, right? And then you want it to be seamlessly done and then be able to visualize it on the dashboard so that when there are failures and everything in it, you'll be able to see it right on the dashboard without diving into the code. So this is the dashboard that gets created and then have it right here for you, right? And so this is the dashboard that gets created based on the predictive and based on the data that we've done so far and the transformation that we have applied. And so here you can look at, be able to figure out where are all the wind turbines that are located, right? And then look at the energy that was produced, right? And look at the percentages of faults that are trend impacted, right? And then also be able to do some maintenance analysis and recommendations based on the data that you have and the model that you build, right? So it gives you really a more in-depth analysis and visualizations as you have developed your pipelines. And that I think really helps on the analytics side in terms of being able to do this. So at the end of the day, you'll be able to, now you're doing the full end-to-end, getting the data, streaming the data in, doing some transformations, right? And these are all streaming use cases, and then getting it final to the machine learning folks. They're doing some machine learning, real-time engineering on it, and then getting the data into the final layer of where maybe your BI folks or your analytics folks want to be able to view and be able to look at a pretty dashboard and be able to make report out of it. And so it gives you that flexibility. And so with that, I would like to then jump back into the DAGs that were created from the pipeline that we run, right? And so the DAG is now completed. As you can see, we have our streaming table. This is the bronze table that got created. And then you have the materialized view, the view that the status table that got created, which is a static one that was coming in. And you can do a full load every now and then to the Parquet. This is in the form of a Parquet file. Then you have your silver layer, right? And so now we did a few joins as well before we get to the final gold layer. So this is basically the DAGs as you see it. Now, each DAG you can click and get more information on it. So when we click on the bronze one, we can see the type of it. We can see the target table. So you can be able to click this target table, and this is going to lead you to where the data is located, right? So this is going to give you access to that. So you have a data explorer, and within data explorer, these are the database that got created and the tables that resides in it. So this gives you that flexibility to be able to see that. And again, right, it tells you here we didn't do any quality metrics on that, right? So that you don't see anything. When we get into the status table that also got created, again, you have access to the pipeline that got created, the table that got created, and also the data quality that were done on it, right? In this case, we're looking at the valid IDs and checking to see if there are any percentage that failed. In this case, telling that one record failed. So you get that information, and then also get to see the schema of that specific table. Similar to the sensor as well. It's the same thing. It gives you more information about the schema, the table name, and where that file is located. And the same applies to all of them. Now, as your pipeline begins to run, you have a lot of metrics and logs to be able to see if there are any issues at all within your pipeline and how to help debug, that. So it gives you that metrics in terms of what is running, okay, how long are things taking. You have all that information here as well. So that gives you that flexibility, right? And so with that, on this right hand side, on top here we have development and production. Now, these are two really like bottoms that you get checked up. So the development, the whole point is that it allows you to reuse a cluster to avoid the overhead of a restart. And so by default, the cluster runs maybe for 2 hours when development mode is enabled. And so that is what the development is there for. So you can, but you can change this within your pipeline configurations, right? You can give it, open the JSON file and be able to edit that. And then on the production side, is I really restart the cluster for maybe specific recovery error, including maybe memory leakages and store credentials. And it allows you to retry execution and events if there's a specific error. For an example, if there's a failure or to restart the cluster. So that is what that is. Then you have the permissions, who to have access to these pipelines. You can grant permission to that. And then you have the settings as well, where you can see it in a JSON format. And then you can also schedule your pipeline as well once you have that completed. Now, once you have all your DLT and everything done, and you want to put it in the workflow, right? You can create basically a job, create a job, and within that job, you can be able to call the different maybe Databricks, the different DLT pipelines that you've created. So you might have maybe a notebook that is going to run first before your Delta Live table pipelines begins to run, right? You might be reading from a file, you might be reading from a notebook, right? You can read it from anywhere. And so that gives you other flexibility in terms of where to read that from, and do all that. And so the workflow is really huge in terms of scheduling your pipelines and having that dependencies from different notebooks. You can also run SQL workloads as well within the workflow, and you can get all that dependencies. And so with that, I would like to pause here to see if there are any questions that you guys might have in the chat. I didn't see any question come through yet. Any questions so far? You can drop a message in the chat because I can't hear. Okay. All right. So I see a few questions here that were asked. Let me attend to that. Any more questions? I'm answering a few questions here, if there are. So yeah, if there are no more questions coming in, I answered a few questions here, but if there are no more questions coming in, I'd like to thank everyone for joining the call today. And I appreciate all the questions that came in. And yeah, thank you very much for joining the call today. Any more questions before I sign out here? Yes, a few more came in. Any more questions? I can stay on for a couple of minutes to answer a few more questions. Any more questions? I can, if you guys have any questions, I can unmute you and you can talk. Yeah, Priyan, did I answer your question, or you say you want all the recordings? Can you hear me?
I want the recordings.
You say you
Can
want
you,
all,
can you share the access?
yeah, the access to all the recordings, right? Is that what you were asking of?
Yes, all the recordings from January to until.
Okay. Yeah, I can get you access to that.
Yes, yeah. Can you just share me the link and the password?
Okay. Yeah, I can do that. Could you send me your email? Do I have that? I think I did. I can check.
Should I share it here or?
you should be able to privately send that to me. I should be able to see that.
If you send, did not understand, sorry.
No, you can, yeah, you can send it to me. I should see it. Just send it, type it out. I should
In the
see it.
chat.
Yeah.
Okay.
But was this helpful?
No, I was not a lot.
Why?
I was not comfortable sharing it in the chat.
Oh, okay. Yeah, I can, let's see if I can message you.
Yes, please. Can you message
Let me see,
privately
yeah.
so I can share it with you?
No problem. Let me try that quick. Let me try.
Yes.
Okay. Let me see. Let me see if I. Do you see when I send a hello to you? Does it come to you straight? I think. Okay, there we go.
Yes.
Okay, I got it. All right, I will do that for you. I will do that.
Okay, I'm waiting.
Pardon?
I'm waiting for
Yeah, I'll send it to you. No worries. After this call, I'll send it to you.
Okay.
Yep. All right. Thank you very much for joining the call today. All right. Okay. Bye-bye.